Under the vast expanse of the celestial sphere, a massive scarlet star, among the most luminous and easily distinguishable stellar bodies, asserts its dominance along the horizon. Situated far beyond our full understanding, this immense cosmic entity possesses the capability of releasing an energy magnitude that could rival the combined radiance of an innumerable array of stars. This astronomical giant, possibly on the verge of an apocalyptic event, may soon unleash a burst of such magnitude that it could outshine 1 billion suns. The real question is, are we prepared for the aftermath such an event could bring? This colossal red star, often referred to as Goliath, resides relatively close to Earth and has emerged as a subject of significant fascination and debate within both the scientific community and the broader public. Recently, this star underwent a considerable transformation, prompting growing concerns among researchers and fueling intense discussion regarding its future trajectory. The most alarming possibility is that this alteration might signal the early stages of a supernova, an explosive stellar phenomenon marking the final phase in a star's life cycle. If Alpha Orionis, the scientific name for this star, were to exhaust its nuclear fuel, it might collapse under its own gravitational pull, triggering a catastrophic explosion. The very thought of such an event sparks anxiety not just among scientists but also for those of us inhabiting Earth, as the potential consequences could be extraordinary. The fate of Alpha Orionis. Alpha Orionis, easily recognized by its deep crimson hue, holds the title of being the largest and most radiant star in the Orion constellation. With the aid of advanced tools such as NASA's Hubble Space Telescope, astronomers have closely observed its behavior, particularly in 2019, when it experienced a dramatic loss of mass, a phenomenon that is considered rare for stars of this type. This raised alarms across the scientific community. While our Sun frequently undergoes coronal mass ejections, CMEs, the unusual event witnessed in Alpha Orionis, has sparked a re-evaluation of what occurs during the final stages of a massive star's life. Scientists are currently divided over the precise distance of Alpha Orionis from Earth. Estimates vary, with some placing it as far as 1,200 light-years away, while others suggest it might be as close as 724 light-years. The difficulty in accurately determining the position of stars like Alpha Orionis lies in the immense distances involved and the peculiar nature of red giants. Despite uncertainties regarding its precise location, Alpha Orionis continues to captivate observers as one of the most awe-inspiring objects in the night sky, shining several times brighter than our Sun. However, this radiant glow comes at a significant cost. Alpha Orionis is consuming its nuclear fuel at a rapid pace, accelerating its journey toward the inevitable end of its life cycle. Once it exhausts its fuel supply, the star will likely collapse, possibly forming either a neutron star or, in a more catastrophic scenario, a black hole, depending on the manner in which the explosion unfolds. Could Alpha Orionis pose a threat to Earth? Should a supernova occur within a few light-years of our planet, the ramifications could be devastating. A supernova can release an unimaginable amount of energy, potentially outshining entire galaxies, which presents the possibility of far-reaching consequences, even if Alpha Orionis lies at a considerable distance from our planet. Historically, the last recorded supernova event within our galaxy took place in 1604, and since then humanity has not witnessed a similar occurrence on a local scale. However, a significant supernova erupted in 1987 in the Large Magellanic Cloud, located a staggering 169,000 light-years away. Although this explosion had notable consequences for its immediate environment, it posed no direct threat to Earth. Nonetheless, these rare events serve as potent reminders of the immense scale of supernova explosions and the dangers they may present. A supernova, particularly one occurring close to Earth, could create what has been termed a danger zone around the stellar explosion. Gamma-ray bursts, a greater threat. While supernovae are infrequent occurrences, gamma-ray bursts, GRBs, represent an even more potent threat. These bursts are capable of annihilating entire planetary biospheres, flooding them with deadly radiation. For instance, GRBs have the potential to destroy a planet's ozone layer, leaving it exposed to harmful ultraviolet radiation from its sun effects that could persist long after the burst itself has subsided. This looming threat of gamma-ray bursts has become a focus of recent research, shedding new light on the potential hazards associated with stellar explosions that culminate in such dramatic and destructive events. When massive stars explode as supernovae, their brightness can surpass that of entire galaxies. This raises an important question. What would happen if Alpha Orionis were to undergo a similar transformation? Should it explode as a supernova, it could become the second brightest object in the sky, second only to the Sun in terms of visibility. Even at a considerable distance, the energy released in such an explosion might be so intense that it could be visible even during daylight hours. This blinding spectacle would cast shadows in the middle of the day, offering a striking yet unnerving experience for those witnessing it. The lasting impact of a supernova. While the visible light emitted by a supernova would undoubtedly be a striking sight, the real threat lies in the high-energy radiation accompanying such an explosion. This radiation, typically in the form of X-rays and gamma rays, would have far-reaching consequences. One of the most pressing concerns is its potential to deplete Earth's protective ozone layer. Without the ozone layer, life on Earth would be exposed to harmful levels of ultraviolet radiation, potentially leading to extinction events. The dangers posed by a supernova do not cease immediately after the explosion. The remnants, including shock waves traveling at nearly the speed of light, would continue to pose threats as they spread throughout the solar system. The cosmic cycle of destruction and creation. Interestingly, some studies suggest that Earth may have already been affected by the aftermath of a supernova in the past. Elevated levels of iron-60, a radioactive isotope produced in supernova explosions, have been detected in deep-sea sediments and lunar soil, indicating that Earth has likely encountered the fallout from such an event within its geological history, possibly within the last few million years. At present, there are no known supernova candidates near Earth that pose an immediate threat. However, ongoing research is continuously uncovering new potential risks, particularly from supernovae capable of emitting long-range lethal radiation. Despite the destruction supernovae can bring, they also play a vital role in the creation of new stars. The material ejected during these explosions serves as stellar nurseries where fresh stars are born from the gas and dust left behind. This cyclical process, where the death of one star leads to the birth of another, drives the evolution of galaxies and contributes to the ever-changing structure of the universe. By studying these extraordinary events, we are unraveling the mysteries of the universe and our place within it, gaining a deeper appreciation for the forces that shape the cosmos. The legacy of supernovae in the universe. As researchers delve deeper into the study of supernovae and their remnants, they continue to uncover the profound impact these cosmic explosions have on the evolution of galaxy star systems and even the potential for life itself. The death of massive stars does not signify an end, but rather a transformation, one that seeds the universe with the building blocks necessary for new stars, planets, and possibly biological life. One of the most fascinating aspects of supernovae is their ability to enrich the interstellar medium with heavy elements. These explosions forge elements like carbon, oxygen, iron, gold, and even uranium, materials that eventually become part of new planetary systems. Without this continuous cycle of stellar death and rebirth, complex chemistry, including the elements essential for life, might never have emerged in the cosmos. Could supernovae influence life on Earth? Throughout Earth's history, it is possible that nearby supernovae have had a direct impact on the planet's environment and even evolutionary pathways. Evidence for past supernova events has been found in deep-sea sediments, where traces of radioactive isotopes such as iron-60 suggest that Earth has been bathed in supernova debris at some point in the last few million years. While such events may not have caused mass extinctions, they could have contributed to shifts in climate, atmospheric chemistry, or even mutations in early life forms due to increased radiation exposure. More speculative theories propose that intense radiation bursts from supernovae or gamma-ray bursts, GRBs, could have played a role in past mass extinctions. If a supernova occurred within 30 light-years of Earth, the resulting radiation could strip away the ozone layer, exposing the planet to harmful ultraviolet rays from the sun. This scenario, while rare, is a reminder of how interconnected life on Earth is with the dynamic processes of the cosmos. The role of supernovae in cosmic expansion. Beyond their influence on individual star system, supernovae have played a crucial role in expanding our understanding of the universe as a whole. Type Ia supernovae, which occur when a white dwarf in a binary system detonates, serve as standard candles for measuring cosmic distances. By studying their brightness, astronomers have been able to determine the rate at which the universe is expanding, a discovery that ultimately led to the realization that dark energy is driving the acceleration of this expansion. This revelation has reshaped modern astrophysics, suggesting that the fate of the universe itself may be governed by an unseen force that counteracts gravity. As research into dark energy continues, supernovae remain one of the most valuable tools in unlocking the mysteries of cosmic evolution. As for Alpha Orionis or Betelgeuse, its fate remains uncertain. The dramatic dimming observed in 2019 and subsequent fluctuations in brightness sparked intense speculation about whether it was nearing the end of its life. While a supernova is inevitable at some point in the next 100,000 years, the timing is unpredictable. Advanced telescopes like the James Webb Space Telescope (JWST) and ongoing studies using interferometry techniques are helping scientists monitor the star's activity closely. If Betelgeuse were to explode, it would create a spectacular celestial event visible from Earth, possibly even during the daytime. However, at an estimated distance of at least 500 light-years, it is unlikely to pose any direct threat to our planet. Instead, it would offer astronomers an unprecedented opportunity to observe a supernova up close, refining our understanding of stellar evolution and the forces that shape the cosmos. The endless cycle of cosmic creation. Ultimately, the study of supernovae reminds us that destruction and creation are inseparably linked in the universe. The deaths of massive stars pave the way for the birth of new ones, enriching galaxies with the materials necessary for future generations of celestial bodies. Every atom in our bodies was once forged in the heart of an ancient star, making us all, in a sense, the products of past supernovae.